Hello everybody. Today we're doing 6-5 properties of logs. We are going to define and apply the properties of logs and the change of base formula. And we're going to expand and condense complex expressions using log properties and the change of base formula. So first of all, let's learn about the properties of logs. Then we'll work on expanding and condensing them. And then we'll talk about the change of base formula and how that can help us turn things into problems we can solve with calculators, which is really, really useful. So, all right, so let's start with the properties of logs. Now, when you're thinking of the properties of logs, you really need to think of the properties of exponents because, like I said, they're very, very similar, right? So before, when we would have a problem, and I'm just going to kind of do this down here, and then I'll kind of relate it up to the top, right? If we have a to the n times a to the m, right, this equals a to the n plus m, right? And this was called the product property, right, of exponents. Well, the product property of logs works similar, but the opposite. If we have a log base b, right, if we have log base b of m times n, this is the same as log base b of m plus log base b of n. In other words, when we do exponents, we say when we multiply the exponents, we add the exponents, right? When we do logs, when we multiply, we add as well. So think of multiplication and addition when it comes to exponents as being linked, okay? And then the quotient property is the exact same thing, right? Before we had, just to kind of write it out here, we would have the a to the m divided by a to the n, and this would equal a to the m minus n, right? Remember this? This was our quotient property. The quotient property still applies to logs, right? And it's the same idea. If we have a log base b of m divided by n, this is the same as log base b of m minus log base b of n. And remember, these two things are very similar, right? The quotient and product property are both very similar. Remember that when we go from multiplying to adding, we can also go from adding to multiplying, right? So we can expand it by going from left to right, or we can condense it by going from right to left. And that applies to both of these properties. Now, the power property of logs, this is a little bit different, all right? But it's still, it's kind of similar. Before, what we had with our exponents was if we had a to the m to the n, right? Like a to the m raised to the m. This was the same as a to the m times n, right? So this is going to look a little bit different, right? But it's the same, it comes from the same principle, right? So if we have log base b to the m, right? Log base b of m, right? And it's raised to the n power. We can actually take that n and multiply it by the whole log, right? Because it's being multiplied by this, it's being multiplied by this, right? We can kind of bring it out to the front in terms of multiplying it by the entire log, like expression, or the log term, right? So in other words, if we have an exponent, we can pull it out to the front and multiply it by the log itself, right? Which is kind of what we were doing before because a log is an exponent. Remember, I've said that a bunch of times. So if a log is an exponent, we're just multiplying the log by the exponent instead of multiplying it by the actual result here. All right, so let's go and try expanding. Let's use these properties. We'll start off pretty easy, right? And then we'll get a little bit more advanced as we go. So let's start off with one where we're going to do just a few, we're going to use a few of them here. So let's expand log base 5 of a squared b to the 7th, okay? In other words, we're going to take, this is all one log form right now, right? We only have one log base 5 of this. We're going to expand it out and to get as much, we're going to take up as much space as possible, I guess is one way of looking at it, but we're going to take each individual piece, right? This is a squared, those are two pieces. B to the 7th, those are two more pieces. We're going to put each piece in its place, okay? So let's go ahead and start this, right? So the first thing I'm going to do is I'm going to take this and I'm going to expand it to log base 5 of a squared plus log base 5 of b to the 7th, right? And the reason we're allowed to do that is because of the product property, right? Remember, if we have two things multiplied together, we can say that they're adding the logs. So here we have a squared times b to the 7th, so we can say log of a squared and then log of b to the 7th, right? And then, of course, the bases always stay the same, right? But this is, you see how the a squared b to the 7th that was multiplied is now added, right? We have two logs now. Now what we're going to do is, this is a squared and b to the 7th. We can move those exponents out to the front because of our power property, right? So where this was once a squared, it's now going to be a, but the 2 is going to come in front, right? And where this was once b to the 7th, this is going to become b, and the 7 is moved out here to the front. So this is our fully expanded answer, right? 2 times log base 5 of a plus 7 times log base 5 of b. And I broke this down into the properties for you, so just kind of make this a little bit easier. If you practice these enough, you're going to get to the point where you're going to see this and you're going to be able to write it out almost instantly, right? You're going to be able to kind of skip some steps, which is, it's a good thing, right? And that always kind of happens when you do math. But for now, I'm just going to kind of take the steps slowly and write out the properties like this, okay? All right, so now let's expand this one. Let's do the ln of 25 over 3, okay? Now remember, ln is just, it's a log. It's known as the natural log. It's a log with a base of e, right? So, but in this case, we're just expanding and working with the logs, so we don't really need to worry about that. But just so that you know where this ln is coming from, just kind of touch on that again. All right, so if we have the ln of 25 divided by 3, remember that using the quotient property, we can rewrite this as the log of ln of 25 minus the ln of 3, right? Because if we look over here, right, m over n equals log m minus log n, right? So that's what we're doing. We're taking the 25 and we're subtracting 3. So ln of 25 minus the ln of 3, and that was using the quotient property. Now, that could be the end of your problem, right? But there are going to be times where your answers, especially on a test, right, might not look like that. It might look like something different. And you're like, where did this come from? Well, what is 25? 25 is 5 squared, right? So we can rewrite this 25 as 5 squared, right? All we really did was simplify. We didn't really change anything, right? We didn't use any rules or anything like that. But the 25 becomes 5 squared. And now that we have an ln of a number squared, we can take that 2 and put it out front, right? So this ln of 3 isn't going to change the rest of the time, right? There's nothing more we can do with this. But because 25 can become 5 squared, we can pull the 2 out to the front, and now we have 2 times the quantity, right? 2 times the ln to the 5th, or ln 5, right? So this here is another final answer, right? This top one is fine, right? But this one's probably a little bit more expanded because we've pulled out as much as we possibly can, right? And your answer on your test could take multiple forms, so it's important to be able to understand that, right? And that's what I put in the note down here, right? This step might actually be unnecessary, but it might be very necessary, right? And in fact, this is actually the more expanded version, so this is what you should be aiming for, okay? All right, so condensing log expressions. So before, what we were doing, right, is we were taking a single log and we were making it into all of this, right? We were taking everything and expanding it as much as possible. Now we're going to try to take all of this, right? We're going to try and push it back into one log. We wanted to say log of something, and that's the answer, okay? So let's start with this one. We have 4 log base 4 of m plus 3 log base 4 of n minus log base 4 of p, okay? So the first thing I'm going to do is take all these numbers that are in front, and I'm going to rewrite them as exponents of our logs, right? So that's, of course, the power property, right? If we go back, right? If we take what we're doing is the opposite, right? We're taking this n and we're putting it back on top, right? So we're converting it back into this form. So let's go back. We have 4 log base 4 of m, right? So that's going to become log base 4 of m to the 4th, right? Which is what this is. And then we have 3 log base 4 of n, the 3 is going to move over here, and we're going to get log base 4 of n to the 3rd, right? The 3 just moves up. And then here, there is no exponent in front, so we just we're done with this step, right? We don't have any more power property we can use. All right, so now I see a plus sign and I see a minus sign. So we know we're going to have to use the product rule and we're going to have to use the quotient rule. Let's do the product rule first. Let's just go from left to right, because that's typically how we do order of operations. So here we have m to the 4th and n to the 3rd, right? Now, because we're adding these, we know that adding and multiplying are intrinsically linked, right? So if it was log m plus log n, that's the same as log mn, right? So that's what we're going to do, is we have these added together here. We're going to multiply them together to reduce the amount of logs that we have. So this is going to become log base 4 of m to the 4th times n to the 3rd. Because remember, when we multiply, we add. When we add, we multiply. We can go back and forth between these forms. This and all of this are the same. And we still have this negative part, right? So now we have our last step, which is to use the quotient property, right? So this is negative log base 4 of p, or minus log base 4 of p. So it's going to be all of this divided by all of this, right? So because they have the same base, we can take this divided by this, and that'll give us our final answer when we go back. Because remember, division and subtraction are linked. So, right, we have log m, which in this case it's like m and n, right? All of this is just considered log m in this case, minus log n, which would be this one with the p, right? So we're going to take those and we're going to divide. So this is going to become log base 4 of m4n3 over p, because the p comes down, right? I know that last step was a little bit tricky, but essentially if you look at it as it's this thing divided by this thing, right? It's m4n3 divided by p. Okay? All right, let's try and condense one more. So we're going to move through this one a little bit more quickly, okay? We have condense 3 ln2 minus 2 ln5, all right? So let's do it. So first of all, 3 ln2, we can move the 3 up on top of the 2, and then 2 ln5, we can move the 2 on top of the 5, right? So this is going to become ln of 2 to the third minus the ln of 5 squared, right? And that's the power property. We kind of did the opposite of the power property, if you want to look at it that way. And now, because this is ln of 2 to the third minus ln of 5 squared, we have a subtraction problem, so we can use the quotient property to divide them, right? So this is going to be 2 to the third divided by 5 squared. Perfect, right? And now the last step is, well, we know what 2 to the third is. We know what 5 squared is. We can just kind of simplify that. So this is the ln of 8 over 25. And you'll notice this is all one log, right? Just that's what we want. We want our answer to be one piece. Okay, and that's what condensing is, right? Both of them have their uses, so you'll need to know both really well. Yeah, and now we've done both. All right, so let's jump into our change of base formula. Now this is going to be incredibly useful because we've done all this manipulating, we've done all these things with logs. We haven't really used it too much to solve problems. Now we're going to be able to use it to solve problems, right? We're going to be able to change the base to anything we need, so that way we can use log base 10, our common log, and we can actually put this into our calculator. And hopefully I don't have to explain how being able to put things into a calculator makes things a lot easier for us. So let's go ahead and do this. So we have log base b of m, right? This is our formula. If we have log base b of m, this is going to equal log base a of m over log base a of b. Now, you're probably wondering where that a comes from, right? Like, where is this a coming from? The point is that the a doesn't matter. It will always be true. We can make a 5, we can make a 100,000. We get to pick the a because as long as we use this form, as long as we keep the a's as the same number on top and bottom, then it will be equal. And if you actually want to go back, you can see this is kind of a quotient rule, right? We had this log here before. You can actually find the proof to show that this works. If you want to look that up, it's actually kind of neat. But yeah, so this is what it does. Log base b of m becomes log of m over log of b. And we're always going to choose a to be 10 because that's our common log, right? And we can put common logs into calculators. So the whole point of changing the base, right? Instead, like we're expanding this into a fraction, but the reason why is because we can put log of 10 over log of 20 into our calculator, right? Like we can put those log forms into our calculator and solve and actually get numbers, right? So what we're doing is we're doing this so that way we can make this a equal 10, right? I know I'm kind of re-explaining myself, but that's kind of the idea, right? If we can take this and rewrite it like this, we can now use a calculator, which is the really big benefit to this. All right, so let's go and evaluate log base 2 of 7, okay? So if we take log base 2 of 7, what we're going to do is remember the base goes on the bottom. It's an easy way to remember it, base to the bottom, right? And then our result will go on top. So log base 2 of 7 is going to be log of 7 over log of 2. Now remember, the a is 10, right? So we don't have to write it because that's what we're doing this as a common log. So really, you can almost kind of ignore the idea that this a is here because in practice, it's always going to be a common log. There's very little reason not to use a common log. Now, this is something you can put in your calculator, right? If you put log 7 and then divide it by log 2, you'll get this, right? You'll get the 2.807. And you can see now how like we took this number here, where normally before, if it didn't have a base 10, we would just be kind of done with the problem, right? Well, now we can convert this into something we can actually put in the calculator. So we can figure out what log base 2 of 7 is now, right? That's kind of cool. All right, so now let's solve this, okay? Just to kind of show you how this like ties in. Now let's solve 2 to the x equals 7, right? First thing we're gonna have to do is put this into log form, right? So let's go ahead and do that. Well, because first of all, we don't know what 2 to the x equals 7 is, right? You should always look at it and just see if you can do it. We know that 2 squared equals 4, and we know that 2 to the third equals 8, right? So we know this is going to be closer to 3 than it is to 2, like maybe like 2.807 maybe. But you can see how this is going to be closer to 3 than 2, hopefully. That's just kind of a conceptual check, right? But let's go ahead and just put this into log form, right? So this is a base of 2, right? Our log is our exponent, so base of 2, and then the x goes here, right? And then our result is what the log base 2 is, so log base 2 of 7 equals our exponent, which is x. So log base 2 of 7 equals x, right? Now what we can do is we can say that log base 7, or log of 7, base 10, over log base 10 of 2, right? We can do this and we can evaluate this, which we did it up here, right? I used the same problem for a reason, right? We still get the 2.08 or the 2.807, but you can see that both of these things are the same way of saying that 2 to the 2.807 equals 7. And like I just said, that makes sense, right? It should somewhere between 2 and 3, and 2.8 is somewhere between 2 and 3. Awesome. So what did we do? Well, we started off by talking about the properties of logs. We went over the product property, quotient property, power property. We then expanded things. We took things from one log and made it as expanded as possible. And then we condensed them. We took everything and we tried to condense it all into a single log. And then we talked about the change of base formula. And the change of base formula is super useful because now we can actually solve things like log base 2 of 7 because we can put them into our calculator. All right, awesome. Well, that's it for this lesson. I will see you in 6-6.